of Xiline's Vivado tool for the design and implementation of digital logics using Verilog HDL. For this tutorial, I have considered the design and simulation of universal gates NOT, NAND, NOR. This is the default GUI of Vivado tool. So let's start the designing. First, create a project. To create a project, go to the file, click on project and new. You can also open the existing project, or you can use the quick start menus. Here we have quick start, task and learning centers. Plenty of options are there. Right now I am clicking on create the project. It opens a wizard which shows that create a new Vivado project. Click on next. It opens another wizard with project name. You can change the project name as per your convenience, and you can change the location. Right now I am using this location. To change the location, you can click on this. Choose the directory for the project file and associated data files. Click on next. Right now I am keeping the default. Click on next. It opens the project type. There are different project types like RTL project is there, post synthesis project, IO planning project, imported project, example project. Right now I am working on RTL project. So enable this and you can specify the sources of the file at the later. That's why it is enabled. Click on next. Now it opens a default part showing the different types of boards that you can use for FPGAs. It has part numbers. You can search here by entering the part number, or you can click on the boards to see what are the FPGA boards that are available. So like Kintex, Ultrascale, Kintex. So there are different types of boards available. Right now I click on the parts, then click on category. It shows different types of applications. Right now the application is general purpose, and the family I am going to choose for FPGA is Arctic 7, and the package type is CPG 236. FPGA has a speed of -1. For this FPGA, it has different package type with LUTs, number of lookup tables, flip-flops used, and various options are there like DSP process, RAMs are there, trans receivers. So like that, many options are available. Right now by default I'm choosing this option. Now it opens the project summary. It creates a new RTL project with the name project 2, and the default part is chosen as this.
पूजा तुम्हारी इंग्लिश न बोल पाने की वजह से द फॉरेन क्लाइंट हैज कैंसिल्ड द डील.
I try, sir, but client not able.
And the default part is chosen as this. The product is Arctic 7, family is Arctic 7, and the package is 236 with a speed of -1. Click on finish. Now it is initializing the project. This is the project manager where you can keep all the sources. It has many files like design sources and constraint and simulation sources. On the left, you have a project manager, which is nothing but your flow, like designing, then performing the simulation, perform the RTL analysis, synthesis, implementation, and program into the FPGA. This is the project summary window. Here we have the design sources as empty. You can add the design sources by clicking on this add sources, or you can click here add sources. Both are same. Click on add sources. Now it opens a wizard with three options: add or create design sources. This is for designing, and this is for add or create simulation sources to create the test bench. Right now I am going to create the design source. Click on next. Then create a new file. You have different options here. If you go here, file type, you have Verilog header, system Verilog, VHDL, memory file. So lot of options are there. Right now I am choosing the file type to be Verilog and create the file name. I'll call this as logic underscore gates. Click on OK. Finish. Now it asks to define the module name. I want to keep the same name. Define the inputs as A, comma, B. Only two inputs I am taking, and specify the output for Y0 for NOT gate, Y1 for NAND, Y2 for NOR. Change the direction to output. Click on OK. These can be defined at the later stage. Click OK. It has created the design source with the name logic gates. Double click on this to open the file. Here it has defined the module, and module name is logic gates with input AB and outputs Y0, Y1. Now you assign the body statement. Use assign Y0 is equal to, I am using the NOT gate, so I am just complementing the input A. Then for NAND, assign Y1 is equal to complement of A and B. Similarly for NOR gate, assign Y2 is equal to complement of A or B. I have completed the design with NOT gate, NAND gate and NOR gate. If my coding is correct, it shows me the green symbol that it is correct. 0 errors, 0 warnings. Save the design. It has updated. Now, before we run the simulation, I can just click on elaborate the design to see the RTL view. It is initializing the device for elaboration to see the RTL view for this module. You can click on schematic to see the, this is what is realized, that is it consists of an AND gate and NOT gate to form the NAND, and we have an inverter here and OR followed by the NOT gate to form the NOR gate. We have realized only the three gates here. They are NOT, NAND and NOR. So it is satisfied. Now I want to check the behavior of this device. For that, you need to create a test bench. To create a test bench, you can directly go to sources and you can click on add sources, or you can add from here. This time you choose the option as add or create simulation sources. Click on next. Create a file. Give the test bench file. all gates, or I will give the name as stimuli. Click OK, finish. So here you don't require to provide any input. Click on OK, click S. It is updating the sources. The simulation file will appear here, not in the design sources, but it appears in the simulation environment. Double click on this to open the file. Now the module is defined without inputs. For this design, A and B are the inputs, so they are declared as registers with A comma B, and outputs are defined as registers with Y0, Y1, Y2 because they are the outputs. Now the logic gate or the module name has to be instantiation. Copy this into the stimulus file that is called as the instantiation.
विस्फोटक आरआर टॉप ऑर्डर के सामने होंगे सीएसके के मजबूत इरादे। देखिए आरआर वर्सेस सीएसके 30 मार्च सोमवार।
महंगाई में कैसे चलेगा घर हमको?
अरे क्या हुआ जी, क्या हुआ?
अरे भाई इतना महंगाई बढ़ गया है, 1000 रुपए में बस इतना ही सामान मिला। बस
देखिए,
that is called as the instantiation. Then provide the UUT or unit under test or device under test, any name here, and provide the inputs A comma B comma Y0 comma Y1 comma Y2. That is inputs and outputs for that logic gate. So now my design is instantiated. Initial, begin, and end. Within this end statement, provide the input combination. That is A is equal to 0. I am writing the 4-bit combination. B is equal to 0. Then provide the delay of 10 nanoseconds. Let me copy this. Change the pattern of input 0, 1. Again, let me copy this entire statement. Click on 1, 0, and another combination as 1, 1. And I want to stop the simulation after a delay of 10 nanosecond. To use that, use the display function as $finish. These test bench statements are true means it shows the green symbol. Save this. This is the UUT, which shows that it is unit under test. It is linked with the stimulus file. Now click on run simulation, run behavioral simulation. Check the waveform window. Verify the design. Use the slider to check the input and output waveform or follow the truth table or not. For inverter, I want to complement the output Y. So this is high and this is low. So like that you can verify all the logic designs. Similarly, you can click on run synthesis to see the lookup table implementation of the design. It is synthesizing the design. So it has completed the synthesis process. Click on open the synthesized design. You can see this. This is the lookup table implementation of this NOT gate. You can double click on it if you want. If the design is large, definitely it will show the inner designs or inner cells. And if you want, you can see the reports as well. Click on power report. This is the power report. And click on report for utilization. So these are present at this window. Now you can click on power report to see the what is the power consumed by the design and as well as the utilization. Here the total power is given, on chip power, dynamic power is there, as well as static power is there, and you can see the utilization.